So this is the first one, which it shows a diagram of an AC generator. Can anyone just confirm that they can hear me? Okay. No, stupid. Yeah. Is that better? Yeah, guys, is this more visible? Right, this is much better. Yeah, that's scary. Right. So what this shows is a diagram of an AC generator, obviously. Right? And then it also shows the PD between X and Y. So as the generator keeps rotating, we have the sinusoidal wave, right? Now, what the question asks for is which diagram shows the position of the coil at point P on the graph. And we have these four options. Now, a mistake that a lot of people make is that they assume that maximum current is at the vertical positions, which it's not. If I imagine the field lines going across, the maximum amount of wire, well, the place where there's the maximum amount of wire in the magnetic field will be in either A or C, right? Because in D, there's only a small amount of the wire in the magnetic field, B and D. Is that a yes, AC generator and DC motor. Anyways, yeah, so we can instantly eliminate B and D. Now the argument is between A and C. So to do that, we look at the positions of the wires. If I look at the wires in A and C, in A it's flipped, okay? So here the short end is up top, and here the short end is on the left, it's on the right. How the most field lines cut when it's horizontal? Oh, okay. See, the magnetic field is directly between north to south, right? So if it was in a vertical position, uh, the full. Okay, I'll talk slower. It's C. It's C. Correct. It's C. This will be shared. Do not worry. I will talk slower. Yeah. So Enrique asked how to explain why this is. I'm sorry. Why the maximum cutting is only in A and C. Again, if the magnetic field lines are from north to south, only in that space, when it's vertical, only a small amount of the wire is moving. Only a small amount of wire is in the magnetic field. However, when I'm in positions A and C, the entirety of the coil is inside the magnetic field. So we get the maximum amount of cutting and the maximum amount of EMF from that. Is that understood or did nobody understand? All right. Yeah. Now, if we look at the positions at A, it means it's only completed one half rotation, right? Because it's flipped one time. That means it's only going to go to the positive peak. So up here somewhere. Now in C, we can see that it's completed a full rotation. Okay. It's come back to the original position, meaning it's going to be negative EMF. How do you know it flipped one time at A? Okay, look at the positions of the wire. On the initial diagram shown, we can see that the short end is to the right. But in A, we can see the short end is to the left. Meaning it's flipped one time. Why won't it be positive? I just explained that. Why won't it be? Again, the direction of current does not change. It keeps moving in that clockwise direction. So when it goes like this, the slip ring is connected. So at the first instant during the first rotation, it's going from X to Y. And in the second half of the rotation, it's going back from Y to X. That's how. I'll move on to the next question. The answer to this is C. Which was the rays of light passing through a converging lens? Can anyone answer this? It looks very simple. No, it's not C. It's B. It's B. All of you are wrong. Yes, correct. A gamer is correct. It's B. So one thing to know is that in a converging and diverging lens, one sec. So we type the lens keyword. Yeah. Look at this. It seems to bend inward, right? Converging parallel, yes, Pierre Gasly. Look, in B, it's pulled closer to the parallel axis. It's pulled closer, right? Wait, let me just. Do this. Yeah. Yeah, guys, please stop typing. Just want all of you to look at this image. Please stop typing. Yeah, please stop typing, guys. Just look at this image. Yeah, look. Why is everybody reacting to the image? Oh my god, it's an image. No, it's not C. It's B. It's B. Look, can you guys see my mouse on screen or not? Like, is my mouse movement visible? Okay, good. In A, this is B. No. Okay. In A, it's obviously diverging, right? Same for D. I am speaking Kalashnikov. I think it's a situation. Right, I'll see. I don't think there's that option in Google Docs. One second. Opening with Paint. Oh god. What? Guys, 1 second. This thing actually closed. I don't know where Wikipedia came from. Exactly. Being kind of tough. You were exactly correct. Can I have the speaker go back? Oh god. I will annotate and show this thing's failed. So give me a sec. I need a mod to give me. Yeah, thank you. Guys, 1 sec. I'll start presenting again. So look, A and C are obviously diverging, right? Yes. So we can just cross them out. Now the confusion would be between B and C. We're trying to figure out which is converging. If we look at B and C, in B it's bending closer to the parallel axis. It turns the top ray. We're only going to consider the top ray, so we can just forget about this one. Let's only talk about the top ray. Here, if we continue the path, we can see it turned right, meaning it turned closer to the principal axis. It turned closer to the principal axis. Exactly. Now in C, it turns away, although it would have intersected like here or something. Instead, it ends up intersecting all the way over here. So it turns away. Meanwhile, this would never intersect. It's just less likely to never intersect. It's closer. Is that you get it? Yeah. Okay. I'm just gonna switch my stream again. the next question. Yeah. Okay. What's the formula for movement in general? What's the formula? Yeah, then you FD. Force into perpendicular distance. Yes, that's what I'm looking for. Now, which way is the force acting? The force is acting directly down, right? At C, it acts at C. Yes, I know you gave this question. That's why I'm answering it. Look, it's acting directly downward. Yes. Here the force acts directly downward, as I said. So downward. Yes, straight down. That weight of 2 newtons. Okay. Now we have to do perpendicular distance. We find perpendicular distance at which is perpendicular to the force. The force is acting vertical. So perpendicular to that, the distance has to be perfectly horizontal. Yes. So that's why we consider QC. We don't consider PC or PQ. It has to be perpendicular to the force, which in this case is QC. That's why we consider this QC distance. In the question, and the weight of the object is 2 newtons. So by simple calculation, 0.6 into, sorry, 0.3 into 2. So answer is A, 0.6. If I understood. It's A. So that I'll explain again. Look, at C, force acts directly down. Yes, perfectly vertical. GG, yes, we know. Kuwait, that's good. Share gone, yes, I stopped sharing. There we go. Yeah, it has to be 90 degrees, exactly. So we have to consider 90 degrees to the force. We have to consider the distance to the pivot, although this is the actual distance. We have to consider the perpendicular distance. I want to consider force that is sideways, perfectly sideways is QC. So therefore, I consider QC as my distance, which will 0.3 meters. We share one sec. Exactly. QC into 2, correct. Because the weight of the lambda is 2 newtons. So 2 into 0.3, 0.6. P is the pivot, correct. V is QC. Okay, I'll move on to the next question. Did everyone understand? Point P is the actual pivot. QC is the perpendicular distance. It's not 0. It's A. It's A. Correct. It's A. It's not 0.6 into 2. It's 0.3 into 2. How did you achieve? What do you mean how clockwise? Look, it's downward. The force downward is to the right of the pivot. It's going to act clockwise. Yes, I am sharing. Guys, I am sharing from the author account. Rejoin. Ignore the bell. Sorry. Alright, did everyone understand or should I move on? Alright, onwards. Okay, this question. Yeah, this one has gotten a lot of people. So the diagram shows the path of a long jump. Point R, where she lands, is on the same horizontal level as point P, from where she takes off. Point P is down here. at the start of the parabola. Long jumper experiences air resistance as she runs and jumps. Remember this point, this is very important. Air resistance. Which graph shows how the store of kinetic energy and the store of gravitational potential energy of the long jumper varies with time between points P, Q, between points P and R. Now, the first thing we can do is instantly get rid of A and C. We know they're wrong because kinetic energy never drops to zero. They mention that she's moving. She's always moving. Okay, even at R, she's still moving. Now, the sum of, well, in an ideal situation where there's no air resistance, it is B. It's B. It's correct. Now we have to differentiate between B and B. Now the key point that I told you to remember, air resistance as she runs and jumps. Meaning while she's in the air, she's going to decelerate. What's the difference? Mankeshwaram, can you see this? D it goes up here, but in B it only comes to here. That's not the answer. That's not how we get the answer. It's not difference between them. Look, kinetic energy in an ideal situation. It's B, yes, yes. How does this person not? Okay. Look, because there's air resistance acting, it's gonna move. It's gonna slow her down, meaning she can't reach the maximum potential. She can't reach her maximum kinetic energy. It looks the same. It looks the same, but look at this. They reach different peaks. Okay, let's look at this. It reaches different peaks. D reaches higher. B reaches lower. Romanus, these questions are from multiple papers. These are hard questions that people sent in. So air resistance is not included in D. Correct. That is correct. So there is air resistance, which is why she can't reach that maximum over here. It's going to be a little lower. So by that we get the answer as B. The gravitational graph is obviously constant. That GP doesn't depend on her speed, it only depends on her height. So yes, obviously parabolic shape. Yes, Blazify, thank you. Guys, please stop asking what paper this is. This is from multiple different papers. These are questions sent in by multiple different people. 2024? Not sure. Xander, you might want to look at the explanation Blazify posted. Right up, just scroll up. Also, guys, if you want this paper, I will send it later. If everyone's clear, can we move on? This works for both, Kizami. Works for both. All right, moving on. The graph shows how the velocity of an elevator varies with time. The elevator starts from the third floor of tall building. Point P indicates the start of the elevator's journey. So over here, over here. Now we use the principle that C, yeah, C. This is very much C. This is just a technique. The screen keeps turning black. I'm sorry. My presentation seems to be fine. Try rejoining. If everyone knows this, I'll scroll down. Alright, I'll scroll down. Okay, there are a couple of people that don't understand, so I will continue with this. Alright, look at this. We use the principle of area under the graph, which I think you've definitely learned in kinematics or something. We have to find the because it's velocity, positive and negative, we can find the vertical distance travel upward and the vertical distance travel downward. And if it returns to the third floor, that means it has to be net zero, right? It's C, exactly. If we find the area of this trapezium, and then we find the area of the triangle, and subtract them, it will be zero, meaning only at the end, at ST, it is back on the third floor. How do we find it? Okay, you should try approximate. Look at the position of Q. It's somewhere between 5 and 10. This is 7.5, like dead center. So this is in between 7.5 and 10, which makes it 8.75. So Q is 8.75. Then you find the vertical distance, the upper distance. Yes, that is correct. This is what I just said. All right, I'm going to scroll down if everybody's understood. All right. The train is traveling horizontally in a straight line. No, this is not C. Yeah, it's B. Yes, it's a goofy question. Look, one thing that we need to know is friction is pulling the book to the right. To the right. Okay. In this case, friction is pulling the book to the right. So what way is the book moving? The book is moving left. Exactly. The book is moving left, while the friction is acting right. Now there's another principle, inertia. So if the book moves left and it's just on a table, if the book moves left, which way is the train moving? The train is moving to the right. Think of it in a car. When it suddenly brakes, you get flung forward. Exactly. So same principle. When we stop, the book moves to the left. Okay, so the book moves to the left, meaning the train is moving the opposite direction. And it's obviously not C or D. It is B, yes, but it's not C or D because if it were moving at a constant speed, then the book would also be moving at the same place. Yes, it is B. Yes, it's B. If everyone understands, I will continue. Is everyone understood? All right. Next question. All right. Four balls with different masses are dropped from the height zone. Air resistance may be ignored. Which ball has the smallest average speed? This is, I'm getting a lot of different answers. Yes, it's A. It's A. It's A. Look, remember that no matter the mass, the acceleration is the same. Weight doesn't affect speed. Exactly. Weight does not affect speed. Had to be C or D, there would be no friction. No, that's not what I said. Look, it's irrespective of mass. And the simplest answer, no, we don't have that formula. But yes, K to MGH we have. Air resistance is ignored. That's irrespective. Look, very, very simple. Just the smallest distance. Smallest distance. We don't need the speeds. They're asking which has the smallest average speed. I'm not going to answer that. How does mass not affect? Look, it is velocity, right? We don't consider in anything like velocity is distance by time. Is that relevant to mass? Do we use mass anywhere? Yeah, but that even in half mv squared, we're equating it to mgh, right? And we can just eliminate mgh from that. We can eliminate m from from both sides. That's it. You don't have to go. It's depending on height, sure. Look, if you want to, you can calculate each one individually, completely irrespective of mass. Use uh wait, does Texit work here? Yeah. So we can use this. Okay, Texit does not work here. Oh, it does. Use this. Now, because there's M on both sides, we can eliminate it from both sides. And what does that give us? Just half V squared is NDH. We get this if we eliminate. So just directly use that. Root V is equal to root 2 GH if I just. Here, guys, if I rearrange that, I just get this. And yes, it's A. That is correct. It's A. You guys can use this on each one, and you will end up finding the answer as A. V is root 2 GH. Kinetic energy is equal to gravitational potential energy. At the maximum, like at the where it's dropped from, the gravitational potential energy is equal to the kinetic energy at the bottom, just before it hits ground. Shortest is not the fastest, actually. Okay, guys, you can try the calculation on each of them. It's going to be, yeah, correct. North is correct. All right, I'm going to move on if everyone's understood. Right. All right, this is a similar principle. Ball is dropped onto a floor. Its speed just before hitting the floor is 3 meters per second. Which change would result in the speed of 6 meters per second before hitting the floor? All right, guys, so I just gave you a formula. Can you see this one? Yes, B is correct. B is correct. All right, I'll show the steps if you want. So, yes, I know it's B, but there are people who don't understand this. It's not A. It's not A. Look, if I have this formula, D is equal to root 2 GH, I have to find the. Now I know it's 2V, right? Meaning I can multiply the whole equation by 2. So something like this. And then you just do math. So what's the answer? It's B. It's B. You guys want to look at the working I'm about to send. So, yep, that's this is pretty much it. Look. So that means I can also multiply. Yeah, just multiply the height into 4. So therefore 4 times the height. You understand? Right, you did not. You are not cooked tomorrow, don't worry. I'm not using the whiteboard. just think of K is equal to MGH and then move around. Yeah, you can also do raw numbers. I will not write your paper for you because I have already written this exam. Ryan, look at what I just sent. Do you understand this? Here, look. So four times height. I am Indian. Yes, I am Indian. Can we forget about this? Like, please, let's stick to the topic. Is 2G ignored? Yeah, because once we divide each other, it's 4. You can try simultaneous equations, and okay, I will move to the next question. Jeez. No, it's not that hard. Where did I get the formula from? I derived it from K equal to mgh. If somebody would like to put that out, okay, after the session. All right, let's move to the next one. Yeah. This is a very straightforward question. I do not understand how this came into the submission. Look, yeah, this is B. This is B. This is B. Yeah, I'm not going to bother explaining this. I don't know why this ended up here. This is a funny question. Thank you, North. Sorry, thank you, Soggy. Oh, no, my bad. Thank you, North. How was that B? Uh, Look, the diode blocks the current. It doesn't act like an absolute function. It just blocks it out. So we won't have these extra humps. A is obviously wrong. C is also very much wrong. We're left with T and B. And D is also wrong because it doesn't turn negative current positive. It just turns it into nothing. So yes, B. AC and diode use. Guys, I will share this doc at the end. Please stop asking for it. Correct SPV. I've already zoomed in a lot. I'm continuing with the next question. Okay. The diagram shows a trace on an oscilloscope screen. The first peak occurs when a pulse of sound is emitted. The second, smaller peak is the echo received from a ball. The trace moves across the scene in a time of 24 milliseconds. How long does it take for the sound to travel to the wall? Now, how would I do this? I'm trying to find time. It's 4.5, yes, but how? I see that you all are very intrigued by this question. So, sure. So, first thing I'm going to do, I'm going to find time per centimeter. We have 8 centimeters here, right? We know that the width of it is 8 centimeters. We know the width of it is 8 centimeters. So I want to find time per centimeter. Okay, I'm not finding centimeters per millisecond. Okay, this is important. I'm trying to find time per. I'm trying to find time per centimeter. It's not B. It is A. Look. So we consider time per centimeter. I will just search. Look, I find the time per centimeter for this. Okay, so 24 by 8, 3 centimeters, 3 milliseconds per centimeter. Okay, and we also know that the distance between each peak is 3 centimeters, right? I want to find time. So yeah, time between peaks 3 into 3, 9 milliseconds. Yes. So yeah, time to wall, because this is 2D, and I want to find the time for one. So because we know the time for both, 9 divided by 2, 4.5. Done. That's it. It's an echo. If anyone's confused, please look at my screen, or please look at what I just sent in chat. Why did we have 9? Okay, look, 9 is the distance to go from the wall and coming back to the wall. What? How did I get this? What do you mean? For time to wall, did we derive from? Yes, yes, we did. We did. Look, it's easier to find time if I do time per centimeter. If I do, 1 by 3 as time as speed, it's much more annoying, but this is much easier. And no, the oscilloscope is not in syllabus. This is a completely conceptual question. Understood. I will move on now. This one. Come on. It's a very simple one. The resulting force. So first, we know that the resulting force to the right is going to be 8 newtons, only to the right. Vertically, it's 6. And then we can do our favorite Pythagorean theorem. Yes, 10. Done. That was decent. Next one. Yep. Here. A ball of mass 0.25 kilograms hits a wall at a speed of 16 meters per second. It then rebounds back along its original path at a speed of 12 meters per second. What is the impulse experienced by it? MV minus MU. Okay. Who said 7? No, it is 7. It's 7. 7. Correct, Ashaz. You were correct. Now, the reason how is it 7? Okay, look. For the first one, it's positive, and the second one, it's negative. Like that. Yes. No, we don't use a direct impulse formula. We know that impulse is also change in momentum, right? So m into v minus u. Numbers, I have the questions in doc. I will share them at the end. No, v minus u is 7. Look, it is minus 12 in 16 because velocity is a vector. Momentum is also a vector. Yes, yes, because opposite direction use minus 12. 4 minus minus 3, 7, correct. Render distance is correct. Guys, please don't abuse latex. Why are we using MV? Look, impulse is change in momentum. Since force is rate of change of momentum, sorry, yeah, since force is the rate of change of momentum, I can multiply force into time to find the change in momentum. So force into time. Does that make sense? Yeah, yeah, we can. Look, they mention directions, right? Back along and hits a wall at this speed. So we can consider positive and negative. Is that understood? Yeah, Mods, can you actually disable text it for the audience? You know what? Never mind. This is fine. I'm going to consider. I'm going to continue. This is a similar principle to the very first question. An aircraft is moving at 60 meters per second in a northern direction, so up. When a crosswind from the east starts to blow, the speed of the wind is 13 meters per second. What is the magnitude of the aircraft's velocity when the wind is blowing? This is Pythagoras, yes. Yes, the answer is C. C. How was it C? Pythagorean theorem, Jack. Who even? Okay, exactly. Whole root of 60, 60 square plus 13 square. Look, guys, velocity is a vector. You can use it in that way. Correct. Correct. Ashing center kite. No, that's not how we do it. Now we take latex for it. This is the latex for it. Yeah. Drawing a vector. Look, it's simple Pythagorean theorem. They said it comes from the east, right? North and east are obviously. Yes, north. I know. Look, it's coming from the east. We know that it's a right angle. North and east are at right angles, obviously. It is basically the resultant force. Exactly. It is a vector. We can calculate it in the same way. Yes, next question. I'm also confused as to how this ended up here. What's the answer? A. Yes, this is A. Everybody has understood this. I'm just going to scroll up. This one. Where did anybody get C from for that? Yes, it's D. If you didn't understand, okay, I'll explain this. Look, for this question, they said it would rest steadily in supports. Right? We're considering two pivots. Okay, look, the simplest explanation is that it's at rest and it's just not moving, meaning that obviously the moments are balanced. The moments about O will be. Oh, you want me to explain the previous question? I'll finish this. Yeah. Some people can understand the previous question. So, yeah. They mentioned that he is moving at constant speed, right? Meaning that net force is zero. There are 19 questions in this, and then I will do a past paper. Yeah. Constant speed resulting force is 0. Yes. Okay, next question. Yeah. This is also very simple. Who's answering this? This is extremely simple. Mr. Meteor, you submitted this. Why are you saying it's easy? Who? Okay, who said B? Why are people saying B? It's A. It is A. How did you get B? Look, it says 0.8, but we are considering the pivot at the wheel. So 1.4 minus 0.8, over here 0.6. So 0.6 into 140 is equal to 1.4 into x. So x is 60. Yes, done. That's it. Yeah, correct. I'm going to continue. Then about, yeah. Okay, this one. Like I said, it's what the pivot is the wheel, not over here. So 1.4 minus 0.8 to get this distance. That's 0.6. Distance from the pivot, exactly. I'm not going to promote physics lab. That's banned. Well, I'm banned. This against the rules. Hello, confusion. Right? Here. Diagram shows part of a hose by a firefighter. 15 kilograms of water flows through the hose each second. Which force is applied to the hose by the water? All of you are saying B because you saw the answer. Does anybody know the working apart from ushers? Correct. 15 into 6 minus 1, exactly. It's just rate of change of momentum. Since time is 1 anyway, so we can just consider mv minus mu, which is 75. Didn't understand. Look, we know that there's 15 kilograms of water flowing through each second, every 1 second, right? Mods, could you set the slow mode to about 20 seconds? Because this is extremely chaotic. Yeah, 20 seconds. I'm serious. Impulse is denoted by I. Look, it is the rate of change of momentum. There's another formula which is flow rate into velocity, mass flow rate into velocity. It's not really in this, but yeah. Everybody's you can just use rate of change of momentum. So all right, next question. I got this just earlier today. The answer to this is D. Yes, it's D. Look, so first thing we know, it does the work against air resistance, right? So it's gonna lose that energy. That energy is gonna be lost to the air resistance. So minus W, which instantly eliminates A, C. and because it ends at a high so D. Yes, D. Okay. This question, somebody sent me a question in DMs. Downwards, as shown, which reflecting electron downwards. Yeah, that was really simple. See, look, the electron moves in the opposite direction of electric field. No, 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 no. Why is it we do not use Fleming's left-hand rule? We are talking about electric field, not magnetic field. You want me to explain this again? Okay, we'll come back to this. Which direction of electric field would also deflect an electron downward? It is just up the page, yes, because the electron moves in exactly. It moves away from the direction. Actually, I think somebody else sent me a question. Just grab that. Come back to that later. This is the last one, and I'll go back to that one. Please wait. The diagram shows a ray of light in optical fiber. Which statement correctly explains the condition for the maximum transition of light by the optical fiber? Yes, this is E. Because look, diffractive index is V1 by V2. Yes, and diffractive index increases with the smaller critical angle. So we're trying to get a bigger a bigger refractive index. Yes, meaning the light has to be slower because V1 by V2. So V2 is smaller. That means refractive index is larger. So if we have a smaller V2, we have a larger refractive index. There's only one condition for total internal reflection. I is greater than C. Yes, Ashaz, just please wait. I will show it. There is no condition on to total internal reflection for speed as far as I know. Light traveling from denser to the other. Oh, you're talking about that. Yes, denser to the other. Cannot move from there to that. Let's go back to this because people are asking. Okay, I'm going to explain this now. Look, the object does work W against air resistance as it travels from P to Q. Okay, so obviously we subtract W, right? Yeah, I'm telling you why we subtract GP. Look, in a normal situation, I explained this to John earlier. So in a normal situation, here we would add mgh and ke, right? Half mv square and mgh, we would add to get total energy. Now the reason I subtracted is because we're completely removing this height. Okay, so all we would usually consider here, but now we're removing this completely because the only actual height here is 0. Right? Uh, There's one more question that somebody sent earlier. So a lot of people made mistakes in this. Which direction is the magnetic field? No, it's not A. It is B. Correct. It's B. It's B. Look, so the rule that we use here is left hand. This is not A. This is B. This is not A. Everybody who says it is A, you are wrong. This is B. We are exactly. We are using the left hand rule. Now we know that circular motion, right? Meaning there is a centripetal force. There's a force acting inward. No, you do not use left hand rule, because if we were using left hand rule on the basic one, as you just said, force is this way and current is also this way, which is why it's wrong. Thing is, force is actually acting inward from this to the center, because centripetal force. So inward. Now put your hand in. So thumb inward, force motion current. Sorry, force magnetic field current. Current is to the let's consider this one. Current is this way, force is inward. So which way is magnetic field? The magnetic field is inward, outward. Correct, correct. Ashlin's is correct. We use that. We use the principle of centripetal force, and looking at those vectors, then we can determine. It's not C, Pierre Gasly. How did you get C? Pointing away from the center of circular motion? What? How did you get C? No. We are not using right hand grip rule, because they mentioned there's a force acting on it. Accelerated. There's a force. Guys, it's B. Please do not spam. Please do not spam. It's not A. It's not A. Oh my god. The sovereign of chemistry. No, it is not A. Look, exactly. Look at Ashlin's thing. Use left hand rule, not right hand rule. It's not A. This is B. This is B. Using the left hand rule, force, current, magnetic field. So current is tangential, force is inward, meaning your index finger is going to point straight out. And I am showing the question. The right answer is B. Look, they said there's a force, right? Acceleration, that means there is a force. What? Look. It's out of the page, correct? It's B. It's B. No, it's not A. Guys, look, it's centripetal force. Forces into the circle. It is not right hand grip rule. It is not right hand. We are allowed to lift our paper as long as you do not show it to other people. Yes, it's B. I don't know why you were saying A the entire time. Okay, guys, that's all of these questions. Should I do a past paper, or or do you guys have any other questions you'd like me to try? If you have any other questions, please send them to DMs. All right, past paper. I'm only going to do one in syllabus, so all right. So the lowest A threshold is S2321. Okay, MJ23, QP21. If you guys like, you can open it. Oh, this paper. It's the only question. It's the only paper I got below 38. All right. A simple one to start off. Wait. All right. You guys see this? Tirumani, I will send the link. Please wait. Okay. To use right hand and left hand rule. Right hand is when there is induced current. So when motion causes current, you use the right hand rule. And when 27. And when current causes force, you use left hand rule. 27th. This one? Oh, this. Twice cross sectional area, twice an. The resistance stays the same as what? One sec. This is B, yeah. Okay, no, I'm talking about the question that was sent by Sasi Brad. It is B. Yes, it because twice the cross sectional area, you multiply the area and you multiply the length. So 2L by 2A cancel 8. It's still L by 8, which is 8. I'm going to return to the first question. Okay, this is very simple. I'm going to skip this. This is D. Here. Terminal velocity, this is also simple. Yeah, here. Okay, try this. This is very, very simple. Oh, question 7. This, I just explained this. I literally explained this question. This one, yes. Let's see. This one, C. Okay. Fourth one. Let me try this. What's the answer to this? It is D, correct. Look, when we need to have the same force, right? Because we're using the exact same spin. We need to have the exact same force. And since the gravitational strength on the moon is 1 by 6, we need to have 6 times the So yeah, 3 into 6, 18. You don't have to know. Look, they said it's 1 by 6 of that, and it's completely irrelevant. We're only trying to find what the mass will be, 1 by 6. So if the weight is 1 by 6, that means we need 6 times the mass to have the exact same weight on Earth, right? No, this is D. This is D. Question 7. Okay, I'll explain this again. Uh, yeah, okay. Look, we have friction, right? Friction acts in the opposite direction of motion. Yes. Friction acts in the opposite direction of motion, right? If friction acts to the right, that means motion will be to the left, right? So motion being to the left. Now we have inertia. Okay, can you hear me now? Yeah, okay. I will send the hard MCQs doc in the study session channel. Please stop pinging me. I will send it whenever it's okay. Yeah, I will send it after the session. So wait. Yeah, friction is to the right. Huh. Friction is to the right. That means motion is to the left, right? Since book moves to the left, I'm sorry, started. Book moves to the left. That means the train has to move in the other direction. Because I'm not pushing the book or anything. It's only the train moving. Okay, has anyone understood the question? If book is moving left, then I should accelerate right. No, that's I'm talking about inertia. Look, if it's moving left, okay, AA, think of it if you're in a car, okay, and there's a sudden brake. You're gonna move forward, right? That's inertia. Same logic. Although the force on the car is backward, you move forward because you don't want to change your state of motion. Neither does the book. The book wants to stay where it was. That's why the book just moves left. Okay, I'm gonna continue. This one. This moment. This is just impulse. Wait, somebody sent me a question in DMs. One sec. Oh, guys, look at the question I just sent. Yeah. Look, a wash basin has an exit pipe covered with a plug of area 12 centimeters square. A chain is attached to the center plug to assist in pulling the plug away from the exit. The wash basin contains water to a depth of 0.08 meters. The density of the water is 1000 kg per meter square. What is the force acting on the plug due to water? Okay, this is a nice question. Can anyone think? Give me an answer. How would I do this? I don't know. Is it C? Is it B? Is it A? Let's work through it because I haven't solved this before, so I have to go through it as well. You're getting C? It's 74 multiplied by shift area force, which is yeah. See, that's the issue. It's not. You guys have got it completely wrong. You forgot to convert. 12 centimeters square becomes you guys forgot to convert this. So it's 0.012. So multiply that into multiply that into 74, which will give us 0.948. But if I done it with 10, then yes, I would have got 0.96. Do you guys understand? You guys simply did the incorrect conversion, nothing else. It is A. It's A. Yes, we always have to look at the question, guys. Please convert. No, guys, please use 9.8 in your exam. Please use 9.8 as gravity. This is a question before 2023, which is why it uses 10. After 2023, everybody uses 9.8 for gravity. So please use 9.8 for gravity exam. I think it's also said on the front page. Yeah, This is the front page. It says to use 9.8. You didn't understand that question? Okay. Check page for Yeah, this one. Okay. Look, I've said this before. Look, the force acts directly downward. So we need a distance that is perpendicular to the force. Imagine like a T. So the distance that is perpendicular to the force in this case is QC, because perpendicular distance. So that's why I do 0.3 into 2. I'm not getting a response from you, but yeah. 0.3 into 2, so 0.6, that's all. Guys, do you want me to solve a past paper in full? Or do you want me to continue with hard questions? No, we don't use vector rule because distance is not a vector. Look, we're using perpendicular distance. Because we're talking about perpendicular distance, it has to be QC, because the distance has to be perpendicular to the force. Guys, if you still have questions, please send them in DMs, not here. And do not ask me questions from the physics channel either. Like, don't send it in the physics channel because I will not look there. Is what A? Yes, it's A. Yes, Q&A. Guys, if that's all with the questions, I can end the session right now. Oh, you know what? Anup sent PDF with hard questions. Should I go through that? I'll just go through the 2025 ones. Yeah, let's go through this, and I will probably end the session after this. Can you see my screen? Okay, I just got a couple questions in the answers. Quite a few questions. I'm not sus. You can check the recording after it's posted. That was the very first question I explained. Guys, I will share the PDF. Please wait. Please wait. Guys, just will stop you. You don't understand which question? Or the first one I'm sharing? Rate of change momentum. Find impulse first. Okay, so that is 1,500 into 0.024. which is 36, right? 36 Newton seconds, and subtract 2.3 from that. What is it? My bad, I used the wrong decimal place. It's 3.6. My bad. 3.6. 3.6. My bad. So yeah, 3.6 is the impulse. So 3.6 minus 2.3, 1.3. A. Because we're reversing the direction. That's why I subtract 2.3. Oh, guys, I'm sorry. I accidentally closed the tab. Uh, can mod send me the thing? Yeah, thank you. Okay, guys, is my screen visible? Yeah. Look, I explained this one. The sun is not the primary source of energy for which these source. Okay, this is A. What? Why is this a question in here? Oh no, my bad. It's B. The sun is not because for A it's actually yeah, it's B. This is B. My bad. My bad, guys. This is B. Because tidal actually comes from the moon. Because the water movements are caused by the moon's gravitational field, which causes the tidal energy. It's not by the sun. So, yeah, my bad. What is the volume of the gas before the plant? Okay. This is Boyle's law. 16th. P1 V1 is P2 V2. That's very simple. So this is 40 centimeters. Yeah, this B. This one. This B. PV is constant exactly. So P1 V1, P2 V2. Zonal, what do you mean the first one? You mean the momentum one? This one. You want me to explain this? Okay, guys, please check back at the recording afterward because it's annoying for me to come back and forth. All right, fine. I'll explain once again. Look, they said tennis ball with momentum 2.3 kg meter per second is struck by a tennis club. It causes the direction and motion of the ball to reverse. Now they gave us the force and they gave us the time, which gives us impulse, right? That means we have a change in momentum, which is 3.6. Now because it's moving the opposite direction, it's 3.6 minus 2.3 because moved in the opposite direction. The answer would be 1.3. A. Sorry, I'm sick. This one. Under which conditions the ray of light totally internally reflected? I'm going to wait for some answers to come. I'll tell you. it's D, correct. Because it just has to be the slowest. Sorry. Yeah. The angle obviously has to be very on the critical angle. That was very simple. This one. Okay. Which length of copper wire of cross section area of this has a resistance R? This is extremely simple. So what is this one? This 27 is the answer. Did everyone get this one? Everyone did. Number one. Yeah. This is a very simple one. We just have to find the actual force applied. So they gave us 2 newtons and 7 newtons, right? So the difference would be 5 newtons. And the length difference is 10 centimeters. So yeah, 5 by 10, 3.5. So B. Guys, please do not send the questions in chat. Please send them in my DMs. I will come back to them at the end after these. What do you guys want me to go through those questions directly? Alright, guys, I'm going to go through these questions because I'm still getting a lot. No, I'm not. Okay. Orbit sent 6 of them. Okay, the thermometer one is removed, but the other ones I'll come to. Oh, guys, I will come back in a minute. Just wait. Okay, guys, give me a second. I'll just put all of these in the Google Doc. Okay. Is this visible? Right. Yeah, 29th. Let's keep our head down this. Which charge state of Oz console behavior in question? Yeah, this is the look in uncharged. What's going to happen is that the positive charges in the sphere are going to move to the right. The negative charges are going to move away. Now, because the positive charges are closer, the strength of attraction will be even greater. Right. So it can move toward. The strength of the attraction is greater than the strength of the repulsion, meaning that even if R is uncharged, it's going to be attracted to B. Yes, both are correct. Positive and. Oh yeah, now 30. Yeah. Okay, that one wasn't asked, so it's cropped out. But there were a couple more questions. Get to them. Yeah, one recent, which is actually sent by something else as well. Okay. The switch S is closed. What's the reading on the voltmeter? It looks tricky, but it's very, very simple. First thing to do is consider this thing as a parallel combination. Okay, so 3 and 3. So 1 by 6 plus 1 by 6, 3 in this case, 3. So this entire thing is 3 ohms. So after that, I can see that the voltmeter is only really across the 6 ohms resistor, right? It is not 6 volts. That's what? No. Look, guys, the answer is the answer is 3 volts. 3, yeah, look, 3, 3 is 6, and then 6 volts. So we distribute it in 3, 3, and 6. This one gets the biggest share, which is 3 volts. We use potential difference formula. Pottometer, nobody said pottometer. I said voltmeter. Okay. This is just potential difference. You just have to consider the right combinations. The answer is not C. The answer is B. Yeah, as I just said, we consider this whole 6 ohm combination as one resistor, which is 3 ohms. The parallel combination becomes 3, right? Yeah, parallel combination becomes 3. So 3, 3, and 6. So we use a potential difference formula. And that's so current is 1 by 2. Yes, current is 1 by 2. To find current, which is 0.5 amps. So 0.5 into 6. So 3. Yeah. Well, let me go on to the next question. This one. Yeah. Diagram show a horizontal wire magnetic field. Can any other things? Guys, if we're still stuck on that question, I'll go back. If everyone's still stuck there, I'll go back. Guys, everyone's stuck, or do you want, or can I continue? I'll go back. Look, this is 3 ohms. This is also 3 ohms because 1 by 6 plus 1 by 6. So then use potential difference formula. Voltage into R1 by R1 plus R2. Or in this case, into this one. Guys, this any okay. No, it's what? How did you get 12? How did you get 6 plus 6? Look, we're only trying to find it across the 6 ohm resistance. So not 6 plus 6, it's just 6. So voltage is 0.5 into 6 only, nothing more. Okay, let's look. Instead of considering the 6 ohm, I'm just going to consider the whole thing as 3. So 3, 3, and 6. So all I'm going to do is 6 into 3 plus 3 plus 6. Sorry, my bad. 6 by 3 plus 3 plus 6. So yeah, 6 into 6 by 12. Is that easier to understand? Was that easier to understand, guys? Or, okay, can I continue? Okay, yeah. This question. What happens to the human balance? So they gave us a wire, okay, and this. Now they mentioned that it's held firmly at each end and cannot move. Okay, the magnets and holder on a balance. Now, some people might think A because the thing gets lifted up. No, because of that magnetic field interaction, it gets pushed down. The magnet gets pushed down. There's no formula used here. It just gets pushed down. It's obviously not C or D, and it can't be A because the only constant course of action here is B. Yeah, look, okay, look, I am not going to consider this thing. This means absolutely nothing. All I'm doing is going to consider this whole thing as 3 ohms, and then just considering the voltometer across 6 ohms. That's all. It's not across 3 and 6, only across 6. Yes. Yeah, that's why it's annoying. You don't. We are only considering this. We are only considering it here. It does not come here because if it is across both this 3 and 6, that means this node instead of being here, the node it would be something like this. Then voltmeter here. That's not what it is. Yeah, you can calculate current. So find the entire thing. 3 plus 3 plus 6, 12. So 6 by 12, 0.5 amps. And then 6 ohms. So V is equal to IR. So 0.5 times 6, 3. Done. I'm not such that question is out of syllabus actually. You will not have this question, but the answer is capacitor. Continuing. This one I explained. Next one before it. What is the new pressure of the gas? I'm still showing paint on my back. Okay. Next one. Here we go. This one is full stop. They mentioned that the tap is open so that the gas can flow to fill both cylinders. So we have to consider 80 plus 20. That's the only mistake somebody will make here. So P1 V1 is P2 V2. So pressure one is so the initial constant is 16 into 10 power 6, so 1.6 into 10 power 7. Now our new volume is 100, right? So divide that by 100, and our new pressure is 1.6 into 10 power 5. So yes, this is B, 1.6 into 10 power 5. The next one. The diagram shows two voltmeters P and Q connected to a potential divider. The sliding connection at point X is moved towards the top of the diagram. What happens to reading on P and reading on Q? Yeah, so when I move it upward, now the distance, Q will have greater resistance, right? Voltmeter Q will have greater resistance in that combination, and voltmeter P will have lower resistance. So the reading on P falls and the reading on Q increases. So that's B. The reason it won't decrease in both, how did you get it in both? Okay, there are questions that are not about electricity, but yeah, there are still more electricity questions. The other two that uh, orbit sent out theories, so I will not be going through those. Okay, look, it's if I have like a billion tiny resistors, it's just grouping them. If I move the arrow up, this is a smaller group of this is a smaller group and this is a bigger group. So there's more resistance there. Yes, this is B. Okay, there's another question sent in. Let's go to that. Yeah. Sent by I'm not sus. Yeah. What is the power dissipated in the resistor and the current primary coil? What seems to be the issue? Okay, so we have this. We have this. Power dissipated. Guys, look, for power dissipated, we use I square R. So we have to find current in the second one. Also, guys, by anything, I will end this meet by 8. I will end this by 8 at a maximum. Yeah. So we can find the current here and then use I square R. Our current here is just 240 by 120, which is 2 amps. So I square R, 2 square into 120. So the power dissipated is 480 watts. And now I have to find the current back in the primary coil. So 480 watts is dissipated. Okay. I will send this log to not worry. Yeah. Look. So after I found the power dissipated, this is 480. Now I have two options. 0.8 and 1.3. I have to find which one. So because power is constant, right? 240 into 2, 480 watts. So here it also has to be 480. So if I want to find current from power and voltage, power divided by voltage is current. So 600 divided by 480. My bad. 480 divided by 600, which gives us 0.8. See. We're done. Oh, sorry for that. Next question. Okay, do you guys all understand this one? The transformer. Okay, if you want to, I can proceed. I think that's all. That's the extent of all the questions that have been sent. If you have any harder questions, okay. Skittle sent one into the next channel. Let's just go to that. Okay, you guys can see this, right? Which ones can be used to determine and to demonstrate electromagnetic induction? This is a very simple one. This is D, by the way. It's very simple. You can obviously use this. Induce current, induce force. Oh my god, look, the copper rod is moved vertically outwards. So use the right hand rule, induced current. Steve, you can DM it to me. Right, so yeah, in demonstration Q, the switch is closed. We generate magnetism here, which generates magnetic field here. So it also generates a current, so voltage. And similarly for this, we use its Lenz law, which yeah, inherently based on that. This is D, correct. Yeah, I think that's all the questions. Guys, last call, final call. If you have any questions, please send them in now in my DMs. I'm not getting any questions, so I'm guessing that's done. Alright, guys, so I will send the PDF to this question. You guys want the PDF or do you want the doc link? Alright, guys, that's all. So thank you so much. All the best for all of you. All the best to all of you. Good luck with your exam tomorrow. Remember, keep a calm head. I will send it right now. Keep a calm head. Do not panic. That's all. And make sure to read the question. If you do not read the question, you will very likely lose marks. So all the best, everyone. Here's a PDF. Okay, I just got last question. Do you want me to explain this? Okay. Look at this thing. The ball stays in the block. Oh, you just consider mass as a whole for the just consider mass as a whole for that. So mv1 plus, so sorry, consider velocity as a whole because they stick together. Vm plus v into m. I will just send the Google Doc link. Yeah, here's the doc link. Okay, guys, I will end the thing now. All the best to all of you.